Hello everyone. In today's video we're gonna discuss about the stack data structure. If you have missed the basics what I have explained in the last class of data structures, just go through, and in today's video we're gonna discuss briefly about this stack data structure. So as we have seen, stack is a linear data structure where the data is stored in a linear format. So the structure of stack can be visualized as like this. Okay, let us suppose this is a base where you can't take out the elements from here. So generally why we use this data structures, like what is the purpose of this data structures? We use this data structure to store and organizing our data. In the organization of our data we'll use these type of data structures like stacks, arrays and linked list. So like stack follows the principle of LIFO. Okay, LIFO or else FILO. So what is this LIFO? It is a principle of storing our data into the stack. Generally LIFO stands for last in first out, which indicates the element which is last inserted can be taken out first. Like how you can take it out first? Let us have a visualized look about this stack. So if you see beside there is some stack like structure. So first we have some data. Suppose you say I have the data something like 1 I have 2, I have 3, yeah, something like 4 elements I have to insert into the stack. I have to organize the data. I have the data like 1 2 3 4. I have to organize this data. See, so how do I insert into the stack? Stack is something like array type of representation we're gonna follow. It's gonna be having a maximum value. Like if you see here, let us suppose this is a stack. I'm having element 1 2 3 4. First I want to insert first element, that is 1. I'll insert like this. I'll insert my 1. Okay, this is my 1. And next I'll insert 2. I'll insert my second element which is 2. And third I'll insert my third element. Okay, see, I'll insert my third element. And now I want to insert my last element which is 4. Okay, I'm inserting my last element. Now I want to delete the element. How can I delete? Can I delete from here? No, I can't, because there is space. I can't access the element 1 from here, right? I can't do this. So this is wrong method of deleting an element from the stack. So what do? I'll delete from here. Is there any base here? No, there is no base. I can easily delete from the top of the stack. This is called top and this is called like bottom. Okay, I can delete the topmost element from this top of the stack. So I wanna delete. Now I'll delete the the last element what I have inserted. I have deleted. So this is the way of deleting the data. I can also delete my 3 and 2 and last 1. Okay, this is about inserting and deleting a data in the stack data structures. Now we're gonna see what is this overflow and what are these underflow conditions of a stack. Very easy way. Okay, let me do this, just a minute. So that is why we have said that like last in first out. So the element which we have inserted last, that is 4, that has taken out first. We can also call it as FILO. The first inserted element will be taken out first. Like we have seen, right? We have seen with the help of stack. Let us take, this is a stack. Let us take the stack again. Okay, this is the stack. I have, this is a base. Okay, the element I have inserted first 1. This is the 2, second most element I have, and this is 3, right? So first I can what element I can take. This is the first inserted one. I have inserted this element first, and this is my last element, right? This is my last element. So I can take the element which is last in the first array. I can take in the first strip itself. I can remove this last element, right? I can take out the I can take out this first element, sorry, the last element in the first time. That is, the last inserted element can be taken out first. That follows the principle of last in, first out. And after removing this, I will delete the second most element, right? And I will delete the last element which is first inserted. This is the element which is inserted first. Now I will be deleting at the last. When I delete this element, are there any elements to be deleted? No. So it follows the principle of last in, first out, or first in, last out. So this is about stack. Now suppose I have a data. Now I have a data like 1, 2, 3, 4 and 5. Suppose I have these elements to be inserted into the stack. Okay, these are individual elements I have to insert into the stack. First thing, for a visual representation, I'll draw a stack. Right, I'll draw a stack like this. So first I want to insert an element 1. I'll insert an element 1 here. Okay. Second, I'll insert an element 2. At third, I'll insert 3. And at last, I'll insert 4. Okay. Now I have one more data, that is 5 to be inserted. But can I insert, is there any place left into the stack? No. Like even if I try to insert this 5, what happens? The stack is like it is limiting itself up to 4 only. But also we are trying to insert 5. What happens? This element gonna fall down, right? If you take a bucket, like simple example in your daily life, you have taken a bucket, okay, you have kept near tap, the water is getting filled into this bucket. Until it reaches to the top of the bucket, the water is filled into the bucket. When you try to fill the water more, what happens? It falls from the bucket down, right? So likewise in the stack also, when the limit is accessed, like a limit is completed into the stack to insert an element, and even though you are trying to insert that element, what happens to that element? That element comes down. Okay, we can't insert. This condition of completely filled stack is called as overflow condition. So see, it is flowing down, right? It is flowing down. So this condition, we'll call it as overflow condition of stack. Okay, this is called as overflow. So I'm very bad with my writing, sorry. Yeah, overflow condition. Yeah, this is my overflow condition. Okay, when the stack is complete.